This is a video of a talk from Crater Remote Conf given to a live audience in February 2016. This video was made possible by sponsors like Modulus.io, okgrow.com, and spacedojo.com. If you would like to find out more information about upcoming conferences, be sure to go to conf.crater.io and put your email in the form that pops up in the lower left corner. Enjoy the video. Hello, welcome everyone to the first ever Crater Conference. If you don't know me, I am Josh Owens, and I'm pretty excited for this, so thank you for showing up. And hopefully, I think we've got a number of great talks lined up. We're doing 4 each day. They all have different links, so if you're in this one, you know, there'll be another link coming afterwards for the next talk and so on and so forth. And then also there's a Slack chat room. If you somehow got this link but you haven't set up Slack, I would advise getting in there as well. I think it's a more general place to chat. Also keep posting the links in there as well. So without further ado, I want to introduce Derek Bailey. Let me see, how do I switch? From Watch Me Code. So welcome, Derek.
Thanks for having me. It's pretty awesome to be here. I love doing these virtual conferences. Somebody in the audience from Australia. Hey, Mark Waite from Australia. It's pretty awesome. Waking up at 4 a.m. for this.
No joke. That's some dedication.
Yeah, definitely.
Yeah. All right. Well, I will let you get into the talk, but just a little bit of housekeeping before we get started. If you're watching the talk, you can leave comments in the sidebar on Crowdcast, and then in the main area, there's a questions and topics. So you can kind of queue up your questions there for the end of the talk, and we'll go through those time permitting at the end. And feel free to upvote. We're going to start at the top and work our way down based on upvotes. So, all right. I'll leave it to you, Derek.
Awesome. I'm going to switch over to my slides to start with here. Title of my talk, of course, is 5 Tips to Improve Your JavaScript with ES 2015, formerly known as ES6. I guess we are officially calling it ES 2015 now, and people are trying to make more of an effort to say ES 2015 with the ES 2016 release upcoming as well. So there's going to be more of a movement in the JavaScript language itself in the coming years. But even with more movement coming down the line, there's already a lot of movement in JavaScript these days. If you've been paying attention at all, even just the tiniest little bit to the world of JavaScript, you probably have been either very excited about how quickly things are moving and how amazing the things are that we can do in JavaScript, or you might be on the other spectrum where you're kind of getting burnt out, where things are just constantly changing and it's impossible to keep up, and you're staying up all night trying to figure out what's going on and what you should be using and where is everything going. And it can be a hassle at times. I mean, even for somebody like myself who does JavaScript professionally for a living, I do client work with JavaScript. I teach other people how to do JavaScript. That's my job. It's overwhelming. There's just so much going on. So it kind of leaves you wondering, well, where do you start? There's so much stuff already in ES6 that it can be overwhelming as it is, and now ES7 or 2016 is coming down the line. So where do you start? What are the most important features in ES6? What are the things that are really going to help you the most right now? And frankly, I had a difficult time picking which things I wanted to show. There's so many great things in ES 2015, ES6 that I use on a daily basis, but I did narrow it down to just 5 things that I want to show you today. And that is arrow functions, the object literal shorthand, which I've also combined with computed properties in object literals, the spread and rest parameters, which are technically 2 separate things, but they're so closely related in syntax, I always show them together. modules, which are incredibly important, especially if you're doing browser-based code these days and want to do, compiled down to a single file. And then destructuring assignments, which is a really powerful way of getting multiple variables out of a single object or single return from various places. So without really any more ado in terms of what features are available in ES6, I want to dive straight into the code here and show you these 5 things that I use on pretty much a daily basis, starting with arrow functions. Now, I've got some code here. This is pretty basic code. This is the kind of workflow code that I would build in my average browser-based JavaScript application, or even a node-based JavaScript application. I've got this function called add new user. And the goal of this function is to run the workflow for adding a user. The first thing it's going to do is get some user detail. And I'm using this callback style of continuation for the function to say that there's some asynchronous work going on. The user is going to be shown some form. There's going to be a call to a server. There's going to be something asynchronous. In this case, I'm just simulating it for the demo code. But the idea is that I want to get some detail for this user. Once I have that, we're going to continue on with processing this add new user workflow. At this point, I've got a user, I've got some detail, I stuff those two things, I stuff the detail into the user object, and now I want to show that user info, maybe as a confirmation screen, maybe as a what you just did, maybe, for whatever reason, I want to call this show user info screen. Can any of you out there, though, guess what's going to happen when I try to call this.show user info right here? And I can't really see any of the comments at this point in time, but I can guess there are some people saying this will or won't work. And if you're guessing that this won't work, well, you're right. This is not going to work. This is just going to blow up in my face right now because the value of this is not going to be correct. It's not going to point to this user workflow object like I want. Now, this is a common problem in JavaScript. The notorious this keyword is easily the most frustrating keyword in all of JavaScript. And there's been a terrible history of misunderstanding it and getting it wrong and being frustrated with it. And there's a lot of great material out there that explains what it is and how it works. And one of the most common solutions to solving this is using that. By creating a variable and assigning it to that equals this, any place that I was previously calling this dot whatever, I can say that dot whatever. I'm creating a closure around this that variable, which I know that's a confusing thing to say, around this that variable. But I'm creating a closure around this variable, and then using that in order to call show user info. This I can't tell you how many times I've done this, countless number of times. But with ES 2015 and the arrow function, I can remove this. I don't have to use var that equals this anymore. I can switch straight over to this arrow function syntax right here. And now I have direct access to this inside of that callback function. So if you look at the differences between these two chunks of code, you'll notice that all I've really done is removed the keyword function and then inserted an arrow right here. So if I switch back to the file, this other file here, there's no function declared right here. And I've added these two characters, this equals greater than, as an arrow function. So what this does is it tells the JavaScript runtime to use the surrounding context of this callback function right here and bind this function to the surrounding this, to this from the surrounding code. What that really means is when I call this.user get user detail, I'm using this as I'm using this as user workflow most likely. I'm going to call user workflow dot add new user, which is going to set this to be the user workflow object. Since I've done that, since add new user is going to be called with user workflow as the value of this, the arrow function right here is going to bind this inside of the callback to say this is equal to user workflow. So now I don't have to use all those hacks and workarounds like I've previously done. I don't need var that equals this. I don't need to do crazy things in order to get the value of this set correctly in my JavaScript. I can just use this simple arrow function and know that the value of this inside of this function is set to the same value as the surrounding code. And that's a very important detail right there, the surrounding code. Because there's an issue that I ran into once where I was using Mongoose inside of Node.js, and Mongoose is an object document mapper for MongoDB. And Mongoose allows me to create a schema, and then it allows me to do things like virtual properties to say I want a property called full name, for example, and I want to add a getter to that property. Now, I tried to use an arrow function on this getter once. But remember a moment ago when I said that the value of this is determined based on the surrounding code? Well, there's a problem, because what is the surrounding code for this get? It's this empty space out here that doesn't really have anything going on. There's nothing there. There's no surrounding code. So it turns out that using an arrow function at this point is a kind of a dangerous thing to do. I'm going to end up setting the value of this inside of my function to the module that contains the schema. That is definitely not what I wanted to do. I wanted to set this to the actual user model object, the object instance, because I wanted to get the first name and I wanted to get the last name and I wanted to format that. So there is some danger to using the arrow function. In this case, I don't want to use the arrow function. I want to use a standard callback function as such, so that I can allow Mongoose and this user schema to appropriately set this for me. So while arrow functions do solve a lot of problems in ES6, and they are one of my absolute favorite features in ES6, they're not a complete solve everything solution. It's not a panacea, a golden hammer that you can just pound any nail with and it magically fixes things. It is unfortunately just another one of the now 6 different rules for mastering JavaScript's this. It's an incredibly powerful rule and an incredibly powerful tool, and I would highly recommend using it. Just note that you need to know how to determine what the value of this is going to be when using that arrow function. Otherwise, you're going to run into bad situations like I ran into with Mongoose and the schema here. Beyond arrow functions, there's a lot of really cool features in ES6 to just kind of simplify our code. And object literals are one of the things that I use all the time. I can have variables and functions and everything all defined wherever I want, however many of these things that I want, and I can collect these things together into an object literal so that I can say do things.one thing, do things.two things, do things.read things, whatever method I want to call off of here. This is just an object literal. It's got a key and it's got a value. Key on the left-hand side, a value on the right-hand side. The right-hand side happens to be pointing to functions in this case. But honestly, this is kind of annoying. I don't like having to repeat one thing, two thing, red thing, blue thing. It's just obnoxious. And it gets even worse when we start adding in additional features and functionality, like trying to determine how the object is going to be composed at runtime based on some variables. So now I have do things with just one thing, two thing, and then I have color things, which include red thing, blue thing, and I'm using a variable called color to determine which color thing I want to assign to the do things object. Well, in this case, I'm assigning a red thing to the do things object. So I can say do things, and I do have a typo there. So I can say do things.one thing, two thing, and red thing at this point. Well, this gets, again, a little bit obnoxious. I don't like having to put all of this code outside of the definition of the object literal. It adds more code than I think there should be inside of the definition of this object, inside of the composition of this object. And that's where object literal shorthand is really going to come in and help us out. The first thing we can do is just get rid of the key value pairs. Instead of saying one thing, one thing, I can just say one thing. And the JavaScript runtime, it's going to know that one thing right here references one thing, this function, and it's going to automatically create the equivalent of that one thing colon one thing. This key value pair is being represented by only the name one thing. And whatever the name of this variable is, that's the name of the key that you're assigning to the object. So when I say do things equals parentheses one thing colon two thing, I can still call do things dot one thing and do things dot two thing. Down below, I have color things, which I've also used a shorthand for. But I'm still doing this do thing bracket color plus thing in order to dynamically assign the color thing that I want to the object. Well, this is where object property, I can't remember the name of it now. Oh well. Well, there's a shorthand that we can use for this now. We don't have to use the long form version of this code anymore where I'm stepping outside of my object definition in order to dynamically determine which color thing is going to be composed into this object. I can do exactly the same thing inside of the object literal. I can use brackets and have color plus thing, and this will be evaluated at runtime to say red thing because I still have color being assigned to red. So now I'm going to take red thing and pull that out of the color things and then assign it to this object so I can have do things dot red thing, just like I did before. So this is some of the syntax that we can add into our code just to simplify things, just to make it a little bit smaller, a little bit easier to read. And I find myself doing this a lot. Again, it's not really this crazy advanced cool thing. It's just less code to have to write. It's less obnoxious to have to read one thing colon one thing, two thing colon two thing. And in my book, saving a little bit of code is definitely a valuable thing to do when you're writing code. Now, I'm not always going to try and write the least amount of code possible. I would rather have my code be expressive than be short. In this case, I don't see those two things in conflict. I see this being expressive and short, so I want to do the expressive and short thing. Now, there are a lot of other features in ES6 that I would like to talk about, of course, but one of the most important features that I've found, other than arrow functions and object literals for shorthand, is the ability to reduce array manipulations with the spread and rest parameter operators. Now, if you've ever written variables that are arrays and you've tried to concatenate those arrays with other values, you may end up with a large amount of crufty code like this. And sure, there are ways to simplify this, like you could say .concat, and you could pass in the B array right here, and it would produce a new array. And there's a lot of different methods and a lot of different ways to concatenate arrays together. The ultimate goal, though, is to end up with an array that has 1, 2, 3, the letter C, 4, 5, 6, and the letter D. Well, with ES6 and the spread operator, which is literally just a ... in front of an array, we can shorten that amount of code significantly. This produces the exact same output as this. It's just a lot less code. And again, in my book, writing less code like this is incredibly valuable, as it just makes all of my code in this file easier to read. I know with this ... that I am going to spread all of the values from this array into the resulting array that I'm creating. And I'm doing the same thing with B over here. Now, spread operator isn't just for putting values from arrays into another array, though. You can do some really cool things with the spread operator, including replacing the foo.apply, the .apply call on methods. If I've got a foo function here, it does nothing more than console.log some arguments. It's a really simple method. And I've got an array of arguments. Maybe you have some dynamic code being generated somewhere. Maybe you have a function where you just don't know all of the arguments that are going to be passed in, and you want to forward all of those arguments to a function call. Well, in the old school code, we needed to use foo.apply or function.apply, pass in a value of this, which of course we just discussed, and then give an array of arguments to be applied to the function above. It's a really common thing to do. But again, this code can be greatly simplified with the spread operator. So if I look at the next file here, we can see that I can reduce that line of code down to just ... args. What this is going to do is spread all of the values of this array across all of the parameters that are passed into this foo function. So if I have more values here, if I have something like 6, 7, 8, it doesn't really matter. I can pass in as many arguments as I want to this function, and this function is only going to have these five named parameters here, but I can spread all of these arguments across this function, and again, reduce the amount of code that I'm using to call this foo function, but also make it easier to understand. When I look at foo.apply undefined, I have to continuously look at this and reevaluate, okay, why is undefined being passed in here? What is foo? Okay, foo is a function. Well, is that function attached to an object somewhere? Should I be saying bar.foo.apply and passing in bar right here? It gets confusing, and I don't really like having to deal with that on a regular basis. So with this spread operator, even if I have the foo function attached to a bar object, I don't have to worry about setting the context or setting the this variable as the first parameter. I can allow the spread operator to just spread these arguments across all of the parameters that are passed into this foo function, and I don't have to worry about it anymore. Again, it's just a nice way of reducing the amount of code that I have to write inside of my JavaScript. Now, the REST params looks very similar to the spread operator. In fact, I got it confused for quite some time, and I tend to lump the two things together because it is essentially the same syntax. It's just the other side of spreading array values across the parameters of a function. Instead of instead of spreading parameters across this function, one of the most common things that you do in JavaScript is take parameters that are passed in and split it into an array of arguments that are passed in. So every JavaScript function has this arguments object that you have available, and this will list all of the arguments that were passed into the function call. Now, I don't like having to do this, but this, again, is a very common thing to do. You want to take all of the arguments passed in, and you want to slice it up into an actual array so that you can do something with it. Well, the spread operator is going to allow you, once again, to reduce the amount of code there. The spread operator looks like the REST params, the REST params operator looks like the spread operator, as I mentioned before, but it's kind of the opposite. Instead of spreading arguments across the parameters of a function, we are going to get the remaining arguments from this function as an array. So this gets really interesting when you start adding in other parameters at the beginning of this function. So I could say something like A, B, C, and what this does is allow me to say, okay, A is going to be assigned to 1, B is going to be assigned to 2, C is going to be assigned to 3, and this args variable is now going to be assigned to the remaining values, 4, 5, 6, 7, 8, 9, and 0. So instead of having to do what I did previously, where I would say A, B, C, and then I would apply this with a parameter of 2 in order to, or 3, whatever it is, in order to get the rest of the values after A, B, and C, well, I can just use this, I can just use this REST parameters to get the remaining arguments as an array inside of my function. Once again, this is all about reducing the amount of code that you have to write in JavaScript, which ultimately is one of the best things about ES6. There's a lot of great ways to reduce the amount of code that you have in ES6, and that's really what I like to focus on when looking at it. Speaking of reducing the amount of code, it's pretty common to have something like array args being passed in here and to grab my brain just went blank. That wasn't what I wanted to look at. So it's pretty common to pass in an array of arguments and take some of those arguments and just kind of pull them apart and deal with them. And this is kind of a terrible example. Normally you would just do A, B, C, but let's pretend that this is something that you might want to do somewhere. You'll have these args. You'll have A, B, and C set up as variables that you're pulling out of this array. Well, there's nothing wrong with this code. This works, obviously. This is something that you can do very easily to get values out of your arrays. But with destructuring assignment in ES6, Once again, you get to reduce the amount of code that you write right at this point in time. So instead of having all of those variables each individually grabbing values out of args, we can use destructuring assignment to say, hey, I know that this is an array, and I want to create 3 new variables at this point in the code and assign them to the first 3 values of the args. Now, this code kind of confused me at first, because when I looked at this at first, I saw, oh, I'm creating an array as variables. Well, no, this is the array syntax, but when the array bracket syntax is used on the left-hand assignment and being assigned to an actual array over here, the JavaScript runtime knows that this is, in reality, destructuring assignment. So this code, this one line right here, is actually the equivalent of these 4 lines out here. Instead of declaring var A, B, and C and then assigning them individually, I am collectively declaring A, B, and C, and then destructuring this array into those variables. So the first value out of this array is going to A, the second value to B, and the third value to C, exactly the same as it was doing here. Once again, reducing the amount of code that I have to write inside of my JavaScript. But it gets better because we're not limited to just arrays. We can also do this with object literals. So we can have object equals A, B, C, standard object literal syntax here. And then instead of using the brackets, we're going to use curly braces to say I'm destructuring from an object. So I'm going to take the key values out of this object and assign them to the variables A, B, and C. It's pretty slick being able to do this. If you've ever had a function where you wanted to return multiple values and you end up returning an object literal or an array and then pulling those values out of that function, well, this is really your solution. This is the easiest way to get those values out of that particular function. There's some really cool things that you can do by combining destructuring with the REST params as well. So in this case, I've got or spread operator as well, whatever it is, REST or spread, I can't remember exactly. Again, I get the syntax confused all the time because REST and spread are pretty much the same syntax, just applied at different places. So let's say, though, that I've got this object literal, and I've got A, B, C, D, E, F. Well, I know that I want A, B, and C as individual variables, but then I want an array of everything that's left over. That's what this syntax here is going to do. This is destructuring assignment using either REST or spread, I can't remember which, to pull all of the remaining values out of object and put them into an array for me. So this leftover, this variable here, is going to be an array with D, E, and F inside of that array. So there's some really cool things you can do with destructuring, and you can combine it with with other things like REST and spread parameters in order to get some really cool effects. So lastly, for the things that I find incredibly useful in ES6, I want to take a step back from code that allows me to do more with less and look at modules. If you're not using modules in JavaScript, you really need to get on that bandwagon. Modules in JavaScript are an incredibly important piece of where things are going. The ability to have an import statement in my code and have it pull code from another file and bring it into this file so that I can use it, as in my simple math example right here, that's a feature that most systems out there already have, most languages already have. Ruby has that, Java has that, .NET has that, pretty much every system in the world has that. But JavaScript historically has not had that until the invention of pre-compilers, where we were doing things like browserify and compiling common JS modules, which looked like Node.js, and compiling those into a single file. Well, now JavaScript has an official syntax to do all of that for us, not only to give us the ability to import code from another file, but also, of course, to export, and then to, at some point in the future, dynamically load those modules from the server as needed. So there's going to be a lot of really cool things sort of happening with modules in JavaScript in the future. And I've shown a really simple example of here. I'm just doing an export default math, which is just taking this math object, which of course I've used the shorthand object literal syntax with, and it's exporting that math object from this file. Inside of my index.js, I'm just going to import my math from the math file, and then I'm going to call my math.add. Well, this is what it looks like when you use the default export from a JavaScript ES6 module. And if you're familiar with Node.js or CommonJS, you might be more familiar with the module.exports equals math syntax. This is essentially the same thing. It gives you the same effect, the same end result. It's just doing it the ES6 way. But there's more features and more capabilities inside of ES6 than just that default method. Sure. So in this second example here, it looks the same from this perspective. But when I look at the math.js file, we're seeing some different code. We're seeing not only that import add from add, which is the same import that we saw previously, the same basic import, but we're also seeing this import with this curly braces around the name. And if you remember from the destructuring assignment a moment ago, well, curly braces when creating a variable gives you destructuring assignment. So I'm saying at this point, create a variable called subtract as an import from the subtract module. And what that's really doing in the background is allowing me to have multiple exports from my subtract module. I'm no longer limited to a single module.exports like I was in CommonJS or Node.js. I can now say export this subtract function right here, and I can say export this constant here, and I can say export some default thing here, and I can have all of these different pieces of my module being exported on different lines. Now, it may look like it's not really a big deal. This might just seem like, oh, well, I just used object literals for that previously in Node.js. But the things that you can do behind the scenes, especially with editors and IDEs that know how to support this export syntax and import syntax, you're going to get a lot of really cool features out of IntelliSense and other things inside of IDEs in the future. You'll be able to do more static analysis like you would be able to do in Java or .NET, because this export syntax is going to allow IDEs to do cool stuff like that. But even without IDEs, even if you're using Vim like I am, which I still think is kind of crazy sometimes, having multiple exports from a file is incredibly valuable. There have been countless number of times where I've gone into a module and just set up an object literal to have multiple exports, exactly like I'm showing you right here. Here's an object literal, and I'm exporting that object literal with multiple things. Well, instead of doing that, I can just do multiple exports. I don't have to export it as one single thing like this. Yeah, sure, in some cases it does make sense to have an object literal that you're exporting, and in this case, I don't have a problem with that. But I'm not required to do this anymore in order to have multiple exports. I can actually have real exports multiple times inside of this file. Another thing that I want to show you here is back in the subtract file. I have this crazy looking object literal syntax here, which says export subbed as subtract. Well, what this is doing is aliasing this subbed function as the name subtract in the export. So that gives you the ability to have internal method names that are different from the external API that you are exporting from this file. Unfortunately, the way they did this with all of this export stuff, export const, export objects, export var, I do think it's a little bit obtuse in terms of the syntax, and I have to constantly look it up. It took me a few minutes to figure out the exact syntax to export an aliased function name at this point. I was expecting it to just be this object literal syntax, but that didn't work. That actually threw an error. There is a very specific formatting that you need to follow for your ES6 module exports and imports. So I do recommend looking that up and studying that, because it is different syntax than you're probably going to be used to. But the end result is well worth the time, as we can now have one common format for exporting and importing files in JavaScript, and we can still use compilers and precompilers and everything to package this up for either Node.js or for our browser or whatever else we want to do. So there's a lot of great stuff in ES6, and I've only kind of really touched the surface with these 5 things that I really enjoy: arrow functions, object literals, spread and rest parameters, destructuring assignment, and modules. But the reality of ES6 is not every environment we're going to work in supports this yet. Sure, we might be able to get it to work in our favorite browser or in our favorite server-side runtime with the latest version of Node, but chances are the end users, especially in browser land, are not going to have all of the latest browser versions, all of the latest features supported. So that just brings up the question, well, okay, all of these features are great, but how do I use them? How can I use this today and actually be able to deliver code that works for my end users? Well, the answer to that, in my mind, is babel.js. Babel is, quite frankly, an amazing little framework that allows you to do a lot of really cool stuff, more than just ES6 to ES5 compilation, which is what we're really talking about, taking ES6 code and compiling it down into code that will run in current browsers and current runtimes. So I want to show you Babel real quick. I'll actually run a demo in this case. It's pretty slick. So I've got my math module set up again. I've got this import my math from math. Inside of my math module, I've got this object literal shorthand syntax. It's pretty cool. It's pretty simple stuff. So I'm going to head over to my command line here. Let me bump up this font size real quick. Go into my code. I'm going to go into my Babel demo, and I'm going to take the code from this source folder and run Babel across it and build it into this output build folder over here. So I'm going to say Babel source /d for destination build. This is going to take a few seconds. There are a lot of things going on behind the scenes, and Babel is doing its thing back there for me. Once that's done, it gives me an output of what happened, and I can load up this build folder, and I can see exactly what this code would look like in today's ES5 code. So I can look at the index.js, which was previously pretty short, just 2 lines of code, and I can look at the build output, and there is quite a bit going on here. There's this require statement here, and there's this math variable and this math2 variable with this interop require default. There's a lot of things going on here that you wouldn't write yourself. But that's okay, honestly. I don't really care that Babel is producing more code for me, because I still get to write really simple code like this index.js file, and Babel is going to handle making it actually run in whatever environment for me. Now, in this case, if you've ever done any Node.js, you're probably familiar with this require statement. This is going to require the math module from the current folder. Well, this math module has an exports.default equals math. Well, this is just the standard Node.js exports. So it's great. I can use this compiled code in Node.js. But what happens if I want to use this in a browser? Well, okay, at this point, you're going to have to get at least one more step added into the process. And that is probably going to be Browserify. Now, if you're not familiar with Browserify, it allows you to take what was written as common JS modules or Node.js modules and compile it into a single package, a single file, a single .js file that your browser can actually run. So I'm going to show you a simple example of that. I've got a basic Express.js app set up inside this last folder here. I'm going to go into that folder, and I'm going to npm start to set up my little browser, my little web server with Express, and I'm also going to run Grunt. Now, I have Grunt configured to do some stuff for me. It's going to watch some source files for me inside of this client app folder. And anytime any of the files in this client app folder change, it's going to run a couple of tasks. It's going to run Babel, and then it's going to run Browserify on the output of Babel. So that's a two-step build process, really. When I change any of the files in this client app folder, I can go over here to source, and I can load up index.js. Let me just fix that little Vim thing real quick. So I can load up index.js. I can save this, go back to my command line, and I can see Grunt is going to run Babel for me. And then once that's done, it's going to run Browserify for me. So Browserify is going to take the Babel output, which I put into this build folder right here. You can see, again, the same output that we saw before, only in this case, I'm including a source map for debug purposes. But we can see the same basic output right here. Well, this code isn't yet going to run in my browser because my browser doesn't understand this require function call. Well, Browserify is going to take that code and it's going to produce a single index.js file for me that my browser can understand. So if I look at this public JavaScript's index.js file, I'll see here, public, JavaScript, index.js. There's all kinds of stuff going on in here that I don't even want to begin to start tearing apart. But this is what Browserify will produce for me. It will take all of the individual files that I had in my source, or in this case, inside of my build folder here, which were compiled with Babel, and it will combine them into a single file that can be used in my browser. Let's take a look at this actually run in my browser real quick. I'll go to localhost 3000. There's my Express app. I'll pull up my console, increase the font size here, so we can see 2 plus 234 equals 236. That's the code that I had inside of this module here. I can change this to say 2 plus 2. For example, I'll change this comment as well just to make sure it's all good. I'll save this, go back to the console. I can see Babel once again doing the build. I can see Browserify doing its thing. Go back to my browser, hit refresh, and now I have all of that code that I had written in ES6 code with modules and imports and exports and everything is compiled down into a file that I can actually run inside of my browser. And if I click on this in order to see the file, well, I'm looking at a lot of crazy things here. I'm looking at some junk that, frankly, is kind of ugly to look at. Once again, that's where source maps are going to come into play. I don't have source maps set up really appropriately in this demo, so I can't show you the easy debugability of source maps in my browser at the moment. But suffice it to say, source maps will help you solve that problem when debugging code in your browser. I've kind of gone through a whirlwind tour here of my 5 favorite features inside of ES6. And I've shown you Babel, and I've shown you Browserify. But there's a lot of other features inside of ES6 that you're probably going to want to pay attention to. And some things that I really wanted to show, but I kind of wanted to distill this down into things that I would highly recommend that you start using today. So some other things that you want to take a look at are things like maps and weak maps. Now, in JavaScript, your standard object literal can only have strings for keys. It may look like a reference to an object somewhere else on that left-hand side of the colon, but in reality, it's just a string. Maps, on the other hand, in ES6, give you the ability to have objects or other things other than strings as your keys for your objects, for the key value pairs. So instead of just having a left-hand side of that object literal be a string, you can actually create a new map and set an object to a value, more like a dictionary in .NET or other languages, where you can have any arbitrary value as the key and any arbitrary value as the value. Now, a weak map is a slight variation of that, where it's a weakly held reference that allows memory to be cleaned up even when it's a part of that weak map. That's a whole different subject, but I'd recommend looking into that. Additionally, in addition to maps, ES6 also introduced the idea of a set. A set, in a mathematical term, is basically a unique list of things. And that's really true in JavaScript sets as well. If you've used a set in Java or in .NET or anywhere else, it's kind of the same idea here. You have a list of things, and it is a unique list. If you try to add the same thing more than once, well, the second time, third time, fourth time you try to add it, it's just going to be rejected from the set. There's also let, which is block scope for variables. If you're not familiar with how variable scope works in JavaScript, var is always scoped to the function, never to an if statement or a for each statement or whatever else. The let variable allows you to scope that variable to the individual block scope, like an if statement or a for each statement or whatever else. There's also const, which creates a constant, an assignment to the variable declaration that cannot be changed. Of course, it's not completely change proof. It's not a frozen object. So you do want to be careful with const, although it is an incredibly powerful feature for simple values that are just hard coded. I use const for simple values as configuration all the time. Promises, which if you're not familiar with promises, they allow you another form of asynchronous code. And promises have been around for a while, But ES6 now includes a native promise implementation, so you no longer have to include additional libraries like RSVP or when or async.js or whatever else. You can just use the built-in promise object. Symbols in ES6 are incredibly powerful, and I'm really sorry I didn't choose to show those to you today because they are something that I use a lot. But symbols are kind of an across-the-board feature and really advanced part of ES6 that allow you to have data privacy inside of your objects. You can use a symbol as a key for an object, and you can guarantee that no other code, well, almost guarantee that no other code can get access to the value of that symbol on your object. And then in terms of simplifying things again, template strings and multi-line strings. Template strings in JavaScript allow you to have a hash, curly braces, variable name inside of a string, and it will evaluate a variable of that name into your string. So you no longer have to do string and string plus some variable string and string in order to get variable values into your strings. Multi-line strings are pretty much what they sound like. You can just hit return over and over and over again. You don't have to do those crazy weird syntax hacks in order to get your strings split across multi-lines. So there are some really good things to look at inside of ES6 beyond what I've shown you here. There are some other things that you'll want to watch, which I don't really use right now. Generators, they are one of those things where there's so much potential for generators to have a ton of value inside of JavaScript, but I don't really see a lot of value right now. I really see generators as a step toward what JavaScript will be able to do in the future. Iterators are related to generators and symbols. You can use a specific symbol called in symbol.iterator in order to get an iterator into your code. It's a little bit confusing to me offhand why I would have an iterator on my code. I don't quite understand why I would use iterators in my objects, except in the case of generators. Generators, if you're not, as I mentioned before, they allow you to do some really interesting things with coding, including what looks like inline asynchronous code in some cases. But generators ultimately allow you to have code that can be partially stepped through one thing at a time. And it does that through the use of iterators. You're actually going to iterate over the function execution every time you have this yield keyword inside of your generator function. I don't really want to go into more detail there. I'm probably confusing people already. It's an incredibly deep and powerful subject in ES6, and I would recommend reading some articles and watching some screencasts on generators and iterators to really understand what's going on there. Typed arrays being the last thing to watch. Typed arrays confused me at first as well, but it turns out they are just a way to do binary data inside of JavaScript. JavaScript has historically been terrible at binary data. We haven't really had a good way of dealing with it directly in JavaScript. We've always had to go back to native code implementations inside of whatever runtime environment we were in. With typed arrays, we can now properly handle binary data. You have typed arrays of like uint16, uint32, or signed integers or whatever else. There's a lot of good features that are going to be built into JavaScript using binary data now, including, I think, a lot of textures and 3D rendering and stuff like that. So there's definitely some cool stuff, some cool things to watch for the future of JavaScript. May not really be useful to all of us, especially not right now, but there's definitely going to be some cool applications of these technologies in the future. Lastly, I do want to mention my one dishonorable mention in ES6, and that is classes. Personally, I think classes were a huge mistake in ES6. I came from a background of .NET and other object-oriented languages, which were very class-oriented. And I fell in love with JavaScript's prototypal inheritance really quickly. And I think what they've done with classes in ES6 was, it was nice from the perspective of people that are coming from other languages. But all they've really done is muddied the waters of prototypal inheritance even further in JavaScript. Instead of fixing the problems with prototypes and prototype syntax in JavaScript, well, they just added more syntax around prototypes without really calling it prototypes. In the end, though, ES6 classes are still prototypal inheritance, but they add a new set of syntax that you need to learn and new sets of restrictions, like you can't put values directly into object literals at this point in time. You still can't have hidden private data inside your classes at this point in time. Both of those things are supposed to be coming in the future, but they're not coming in ES 2016. It's going to be beyond that, probably ES 2017. I really think classes are something that you should look at to understand, because you're probably going to see other people writing classes. But in my book, I would avoid classes at this point, at least until they actually make them really usable by adding all of the missing features that are out there. But with that, that's pretty much my walkthrough of ES6 and what you should be looking at. You should be looking at arrow functions. You should be looking at simplified syntax with object literals, be using REST and spread parameters, using the destructuring assignment, and of course using modules in your code with probably Babel and Browserify in order to make your code compatible with your current JavaScript runtime environments. And if you're doing things like Meteor, which I gather a lot of you in this audience today are, you're probably already set up with ES6 modules in Meteor. I think Meteor has that built in at this point. And if not, you should be able to add it pretty easily. So I do want to say thank you for watching and listening. Hopefully this talk will give you a little bit of an idea of what you should start looking at in ES6 and help you down that path a little ways. And I do want to say, if you do want a little bit more help and assistance getting down that path, I do have some screencasts at watchmecode.net where I learn ES6 live. It's an unedited, no-holds-barred recording of me trying to learn some of these features, figuring out Babel, figuring out arrow functions and symbols and generators and more, recorded for you to learn along with me, along with a lot of other screencasts that I have for Node.js and JavaScript in general. So hit up watchmecode.net and be sure to use the CreatorConf discount code to get 35% off. You'll get a monthly subscription for $9 a month instead of the usual 14. So thanks again, and I'll turn it back over to Josh at this point.
Hey, yeah. Thanks, Derek. That was a great talk. Everyone seems to be loving it. All right. So we'll just do some questions real quick. So the first question is, do you feel like some of the ES7 plus features are worth using today, since we have to use a transpiler anyway to get it, into browsers and stuff?
I say a cautionary yes. The challenge that you're going to run into with using ES7 features and beyond is that syntax may change at some point in the future, especially if you're using early stage, like stage 0, stage 1 stuff, where it's a proof of concept that you would be using. So if you look more like, I think it's either stage 2 or 3, where it's a recommendation that people are trying to approve. If you're in that stage, then yeah, I'd say definitely start using it. If you're already using Babel is probably going to have that feature built in. You might have to set a specific flag to get it enabled, but there's a lot of good features coming in the future of JavaScript that may not be in ES 2016, but are already a part of Babel.
Yeah. And if you're using something like Meteor, I know in 1.3 we're going to get module support, but also there's a polyfill for promises for async and await, and so nice. That's kind of interesting too, because they're actually wrapping all that up in fibers for you behind the scenes.
Very nice. There's also a talk by Kyle Simpson, otherwise known as Getify. He did this talk at November, just this last November, where he talks about generators and doing a lot of really cool stuff with async operations using generators. And I would highly recommend watching that talk to see more what you can do with generators and async stuff. And I think there may be some room for compatibility and use inside of Meteor apps, just based on what little I know about Meteor.
Nice. All right. So speaking of generators, I don't know, this is like, Ben put this in a very specific context, but what are some ways that generators can be useful in Meteor apps?
Well, unfortunately, I can't really answer that since I've never actually built a Meteor app. I kind of get the idea of what it is, but I haven't had a chance to sit down and use it. So I would have to defer that to somebody else.
Okay. We'll skip that one for now. So I asked, do you think that it was a mistake or that it was bad that they left out the skinny arrow with ES6?
No, I don't. And I'm assuming you're referring to the way CoffeeScript managed this inside of Skinny Arrow versus Fat Arrow. I think they did the right thing by not doing that. CoffeeScript aimed to solve this problem with Skinny Arrow, Fat Arrow, and all they did was make it worse because the way Skinny Arrow and Fat Arrow worked was dependent on surrounding code, and there's just horribly complex set of rules that you had to understand around those two different syntaxes. Keeping it simple with just the Fat Arrow was the right move, in my opinion. I never liked the way CoffeeScript had two different versions of that.
Yeah, I guess I just missed the shorthand. Like you referenced like overuse of Fat Arrow, and I find most people overuse the Fat Arrow because they just want the shorthand syntax. And
the Fat Arrow isn't really about the syntax. I mean, you're saving like 5 characters of typing, which really isn't worth the savings in terms of the syntax. It's the functional aspect of binding this inside of the callback that really makes the arrow function valuable.
Yeah. All right.
I think I addressed this next topic in the talk itself. Yes, we do have to worry about browser support when adopting ES6, and that's where Babel is really going to come into play. If you want to do ES6 in your browser, certain browsers have certain features enabled. I know Chrome, for example, lets you do generators. It also has promises and it has arrow syntax, or at least I think it has arrow syntax. But there are a lot of features that aren't in browsers yet, and you will want to use Babel to support browsers.
Yeah. And if you are using Meteor, that's that stuff's all kind of built in. So we're already getting Babel kind of cross-compiling down and getting everything ready for the browser for you. So that's kind of nice. All right.
Do I think ES 2015 and beyond makes CoffeeScript obsolete? No. I've never been a huge fan of CoffeeScript, I'll admit. I've worked with it quite a bit. One of my clients and now a good friend was madly in love with it for a long time, so that's what we used on his projects. But I think it was Brandon Satram, a former coworker of mine and a product manager at Telerik, who basically likened CoffeeScript as the roadmap for JavaScript. CoffeeScript has done a phenomenal job of informing the JavaScript community of where JavaScript can and should go. And I think CoffeeScript still has a lot of value in that front. I don't personally like CoffeeScript. I think they made a lot of mistakes in the syntax and things that they did with it. But I still think CoffeeScript is valuable as a forward movement kind of map. I know ES6 or ES7 and beyond in Babel kind of gives us that now with the ability to play with syntax and use it early on. But I think something like CoffeeScript and TypeScript and all these other precompiler languages out there are really good at showing JavaScript where it can go.
Yeah, awesome. All right, so we'll end it there. If anyone else wants to chat with Derek, I'm sure he'll be hanging out in the Slack room, and you can put your Twitter and your Watch Me Code site in there too, Derek.
Yeah, definitely. I'm everywhere at Derek Bailey, so derekbailey.com, Twitter at Derek Bailey, all that good stuff.
Awesome. All right. Well, I put the link up to the next chat, so if you're gonna follow along on that one, hop in there, and we'll get started in just a minute.
All right. Thanks
everyone. Derek. This video has been a Space Dojo production. You can click the Learn More button to find out more about us at spacedojo.com. Or you can click the subscribe button to get notified about new videos we put out each week. Thanks for watching.